Okay, so welcome to today's lecture. So we are going to be dealing with Engineering Mathematics 2, Biomedical Engineering, 2024 July August. That's the past paper we're going to be dealing with, because a lot of people are crying for the answers for this same past paper. Okay, so the first question that we are going to be dealing with, question 1. The question reads, an alternating voltage of 240 volts 50 Hz is connected across an impedance of 60. This is the impedance that we've been given, 60 minus J100 in brackets, then the ohms outside. So the question says, determine the resistance, 2, the capacitance, 3, the magnitude of the impedance and its phase angle, then 4, the current flowing. So moreover, this is part of the complex numbers. These are complex numbers. So according to what we learned on the complex numbers, this part here, this part is what we call, these are real parts. Then this part here is what we call the imaginary part. So we have what we call the real numbers and the imaginary numbers. The imaginary numbers are the ones that do carry this J, the I's. Others, they use I here instead of this J, but here we're using this J. Okay, so if you just see this, the number on complex numbers, the number carrying actually a letter either J or I, just know that that's an imaginary part. Okay, so now since here this question is talking about the impedance, this is what we call the impedance, and we know that the formula of the impedance, if you come to electricity, it's Z equals to R. If I put a negative here, if the imaginary part is negative, the reactance is capacitive. If this imaginary part here is negative, meaning they're telling you to say the reactance that you are dealing with is what? Is capacitive. But if the imaginary part here is positive, they're telling you to say the reactance you're dealing with is what? Is inductive. But here we have this negative, meaning the reactance part we are dealing with here is what? Is capacitive. So I'm going to have minus XC. This symbol here is the inductive capacitance. This is the symbol of the inductive capacitance. So this is what we call the capacitive. This one here. So this is the formula. So now the first question, it says, what is the resistance? So according to this formula here, we have R. If we get this and substitute into here, the R here is the resistance. This negative here, it's showing you that the reactance that you are dealing with is what? Is capacitive. So this is the capacitive reactance. Here, this is the capacitive reactance. Okay, so the first question says, what is the resistance? So you just say your R is equals to what? To 60 ohms. You're done. You go to question, you get your 2 marks. You go to the capacitance. The second question says, determine the capacitance. How are you going to determine the capacitance? Simple. So since now you know that this is the capacitive reactance, this is the capacitive reactance that you've been given here. So what is the formula of the capacitive reactance? The formula of the capacitive reactance, it is the capacitive reactance, which is equals to 1 over the capacitive reactance, which is equals to 1 over 2 pi the frequency that you've been given, you multiply by the capacitance that you've been given as well. So this is the formula. So now how do you determine? So since you have this formula here, how do you determine the capacitance? It's just a matter of substituting. You know that this here, the reactive capacitance you've been given, that it's what? It's 100. So just substitute. I'll have my 100 here, which is equals to 1 over the 2 pi. This I can punch it on the calculator. What else am I given in my question? I've been given the frequency of 50 Hz. So I'll multiply by 50 Hz. I'll multiply by the capacitance, which is the one I'm supposed to calculate. We have something like this. Okay, so what do I do here? So I'll just go straight with this. I can punch this on my calculator. So if I say what is 2 shift pi, I multiply by 50 Hz. I'm going to have 314.1 159. So here I'm going to have my 100. I'll put my 100 equals to 1 over. If I multiply what is 2 pi times 50, this is the answer I'm getting, 314. So I'll write my 314 here down. 314.159. I multiply times the capacitance, so I'm going to have 1.59 C over 100/1. I multiply again. This is simple math. So it will be, what is 100 times this? So if I multiply this answer, the answer that I have gotten times 100, I'm going to have 31,415. I'm going to have 31,415.927. I just round it off, C, which is equals to 1. Then I will divide everything by this same for me to remain with C, because our interest is for us to calculate what? The capacitance. So I will divide by 31,415.927. Also here, whatever I do from my left side, I have to do it from my right side as well. 31,415.927. So I cancel this and this goes. I'm going to remain with my capacitance. So the capacitance that I'm going to remain with, which is equal to, now this, if I divide this, so the easiest way, since I have this answer, so the easiest way of what I've been taught by one of my lecturers is just to go direct. The inverse of this, then you multiply. Okay, sorry. The inverse of this, then you multiply direct with what? With 1, because it's the one that you're supposed to, it's the one that you are supposed to have. So this one becomes your final answer. It's just simple. This one becomes your final answer. So this is how we calculate these answers. So I have this. So what I can do is I can just move this one. Since I have 3.183 times 10 raised to the power negative 5. And we know that the capacitance is measured in what? The capacitance is measured in what? In Fahrenheit. Okay, so we're going to have this F. So you can have this, or you can move this point, then you add here to be -6. So if I have -6, meaning it become a micro. So I have C equals to, I can have my 31 here. If I move this point, it will be 31.83. Instead of me writing times 10 raised to the power -6, since I've moved a point, I'm just going to write this micro F. Okay, so since we know that the capacitance is being measured in farads, so we're going to have this one. So it will be the capacitance equals to 31.83 microfarads. So this one becomes your answer for 2. We go to 3. Okay, so what do 3 tells us to calculate? Question 3 tells us to calculate the magnitude of the impedance and its phase angle. So how do you calculate the magnitude of the impedance together with its phase angle? Okay, so now for us to calculate the magnitude, in math, if you're dealing with magnitude, it's just the same throughout. Wherever you're going to find it, if you're dealing with electricity, electronics, electrical technology, you are dealing with something which deals with calculations. Even in computer, if you have to find the magnitude, this is how we solve it. So how are you going to determine the magnitude of its impedance? So this is how we show the symbol of the magnitude. Now we get the formula of an impedance, which is equals to R minus XC. We square it. So this is how we do it. This is how we do it. Now don't forget that since we are dealing with this one is supposed to be in bracket, sorry, we add this one is supposed to be in bracket, sorry. Okay, we have something like this. Don't forget the negative here. Okay, sorry. We have something, yeah. So this is how we do with what? With the magnitude. So we proceed. Your impedance, the resistance we've been given that it's what? It's 60 squared plus What is our reactive capacitance? It's negative 100. Square it. So if you do your math, well, you're going to find that you can just punch everything on the calculator. What is 60 squared plus 100, or we just say negative 100? Still, it's just the same thing. Squared. You're going to have this one. Then the square root of this, you're going to have 116.62. So we're going to have 116.62. 116.62, and the impedance has been measured in what? In ohms. Okay, this one becomes your final answer. Okay, so we proceed to the fourth question. So, and its phase angle. Sorry, we had and its phase angle. So we're supposed even to calculate the phase angle of this. So how do you calculate the phase angle for this? So this is how we do it. So the phase angle for this, we're going to have the arc of z, which is equals to the tan. I hope you know all these things. Here we're going to, the imaginary part always becomes the numerator. These are the rules of, these are the rules of the complex numbers if you want to calculate the angle. So it will be the arc of z, the arc of the impedance is equals to the tan of the imaginary part, which is negative 100. You divide it by the real part. So on my calculator, if I divide what is negative 100, I divide it the real part, which is 60. I'm going to have a negative 1.66666. So how do you come up with an angle? You just place your shift, then tan of this. So I'm going to have negative 59.036. So this one becomes my angle, which is equals to negative 59.036. So this one becomes my angle. So don't get confused to say, okay, but why is he calculating the angles in the angles in negative forms? This is the angle that have been given, and we are dealing with, the reactive capacitance. That's the one we are dealing with. We're not dealing with the reactive inductance here. We are dealing with the reactive capacitance. So the capacitive that we are dealing with here, it's what's this? The imaginary part that we are dealing with here, it's negative. So these are the answers you're going to be getting. We move forward, we go to the current flowing. So this is how we calculate the current. Okay, so this is the fourth question. How do you calculate the current? So this is how we do calculate the current. So the current, we know that current, this is the formula. Current is equals to the voltage over the impedance. Okay, so now when it comes to the complex numbers, how do you present your voltage? I have the voltage that I have been given of 240. So I'm going to have the 240, and this voltage, it has 0 degrees of an angle, over the impedance. We calculated this with together with an angle, together with its angle. Okay, so the impedance, we've been given that we have 116.62. What is the angle that we've been given? Negative 59.036. Okay, so this is what we have. Since we have this, then now how do we divide? So if you're dealing with complex numbers and you are dividing the angles, what do? We subtract. But if you are dividing the real part, what do? It's just direct. Since here now we are dealing with the real numbers. Here we are dealing with the angles. These angles we are dividing. So these ones, if you are dividing, what do you do to this part here? You just have to subtract. But to this part here, what do? It's direct. You just divide. Okay. So if I divide here, what is 240? I divide it by 116.62. I'm going to have 2.05, or I'll just say 2.06. Okay. So meaning here my final answer for the current flowing, I'm going to have my 2.06 with an angle of what? If I subtract what is 0 degrees minus negative 59.036, I'm going to have 59.036. 15.036. This is just simple math. There's nothing like calculating. So this one becomes the current which is flowing together. So this becomes your current which is going to be flowing throughout that alternating voltage of 240 volts, 50 Hz, which is connected across an impedance of that impedance that you've been given. So these are your final answers. Maybe someone might be asking to say, how come it's now positive since it was negative? So negative 59. I mean 0. You have your 0 here. If you subtract minus negative 59.036, negative times negative becomes a positive. So it will be 0 plus 59.036. We're going to have 59.036. So it's just a simple calculation or just simple math. Okay. So we go to question B. Question B, the question reads, solve the equation. It's just solving the equation, guys. So question B, solve the equation. We have 2 minus J3, which is equal to the square root of A plus JB in brackets. Okay, so now how do you deal with this simple math? These are complex numbers. Okay, so the first thing that we have to do, let's take away this the square root. So how do you take away this square root? You introduce a square. So a square and the square root goes. So a square together with the square root, it disappears. So we are going to remain with 2 open bracket 2 in bracket, minus J3, which is equals to A plus JB. Okay, we have this. From this point here, let's try to simplify 2 minus J3 in square. So we are going to have 2 minus J3, again 2 minus J3, which is equals to A plus JB in brackets. Okay, so now here, it's just a matter of, we are trying by all means to simplify this. So if I multiply what is 2 times 2, I'm going to have a 4. 2 times negative J3, I'm going to have negative J6. Negative J3 times 2, again, I'm going to have negative J6. What is negative J3 times negative J3? I'm going to have positive J squared 9, which is equal to A plus JB. Okay, so from this point here, negative J6 and negative J6 are like terms. So what do I do with these like terms? I sort them out. So to be 4, what is negative J6 minus J6? I'm going to have negative J12. Remember the rules of algebra, the rules of integers. If you have a negative and a negative, you add, you get the sign of the bigger number. So I'm adding, what is 6 plus 6? This is where this 12 is coming from. Then now I add, I get the sign of the bigger number. Which one is big between 6 and 6? They're all the same. So I just pick a negative because they're all carrying the same sign. Okay, so plus J squared 9, which is equals to A plus JB in brackets. What next? The J squared here, the rules of complex numbers, it tells us to say, if you have a J squared, meaning this J squared, it represents negative 1. But if it's just J, it represents the square root of that. Okay, so I'm going to have 4 minus J12, because there's nothing I can do with this, plus, let me try to simplify this. J squared, it's negative 1, those are the rules. 9, which is equals to A plus JB. So it will be 4 minus J12 plus, what is positive times negative 1? I'm going to have a negative 9 here, which is equals to A plus JB. Okay, so from this point here, I collect like terms. 4 and negative 9 are like terms, so I put them together. So it will be 4 minus 9 minus J12 equals to A plus JB. From this stage, what next? 4 and 9 are like terms, so I subtract. That is 4 minus 9, I'm going to have a negative 5 minus J12, which is equals to A plus JB. What is A plus JB? So this one becomes, what am I supposed to do here? Negative 5 minus J12 is equals to A plus JB. So here it says that A is equals to negative 5 and B is equals to negative 12. So these are my two answers. I'm done. So you get your 20 marks just solving this question. You get your 20 marks just solving this question. So we go to question 2.